Okay, here is assignment number 1 worth 20 points. It's a little bit tricky, plus there's some stuff we haven't covered yet, so I'm going to help you with it. Let's do this first one. Let's do this one right here. As you can see, it's all hydrocarbons, carbon and hydrogen, and all single bonds. So it is going to end in ane because it's an alkane. Let's figure out the longest chain. 1, 2, 3. Nope. 1, 2, 3, 4, 5, 6. Probably not. 1, 2, 3, 4, 5, 6, 7, 8. Maybe that's it. 2, 3, 4, 5, 6, 7, 8, 9. 9 is the longest chain, so that's going to be a nonane. Nonane. Okay. So this is a nonane. It's got some functional groups about the longest chain. There's one, there's one, there's one, there's one, and there's one. So what is the order of counting? If we start here, we get to the first substituent after 2 carbons, 1, 2. We start here, it's 3. 1, 2, 3. So the counting order is going to be in this direction. So let's just make a table of all of these groups. 1, 2. That's a 2-methyl. 1, 2, 3, 4, 5, 6, 7. That's a 7-methyl. 1, 2, 3, 4. 4-ethyl. And 1, 2, 3, 4, 5, 6. 6-ethyl. And 1, 2, 3, 4, 5, 6-ethyl. Another 6-ethyl. So these are all the substituent groups. So E comes before M, so this is going to be a 4, 6, 6, tri-ethyl, and a 2, 7, dimethyl nonane. So this is 4, 6, 6, tri-ethyl, 2, 7, dimethyl nonane. All right, let's move on to this one. As you can see, it has a double bond in it, so it's going to end in ene. Longest chain is going to be 1, 2, 3, 4, 5, 6, 6, 6. So this is a hexene. Now, it has a substituent group. So, and the order of the double bond, let's do that first. Order of the double bond is 1, 2, 3 in that direction, or 1, 2, 3 in that direction. So it's going to be a 3-hexene. It's got a substituent group. We could number it in this direction, 1, 2, 3, 4, 5, or we could number it in this direction, 1, 2. We picked the lowest one. It's a methyl group. So this is going to be 2-methyl 3-hexene. 2-methyl 3-hexene. Okay, let's go and move on to this next structure, which is right here. As you can see, it contains only carbon and hydrogen, so it's an alkane. So it's going to end in ane. Longest chain, 1, 2, 3. 1, nope, 1, 2, 3, 4. So 4 is the longest chain. So we're going to call it a bute. So this is a butane. It's also cyclized, so it's going to be called a cyclobutane. there are two substituent groups. There's a methyl group. There's a propyl group. All right, M comes before P, so this carbon gets the 1. So this is going to be a 1-methyl. Here's a propyl group on carbon 2, but it's a special propyl. It's an isopropyl. So this is 2-isopropyl cyclobutane. 1-methyl, 2-isopropyl cyclobutane. Okay, let's try this compound. As you can see, it's aromatic, has a benzene ring in the center. But is it a special aromatic? Does it have that special name? There's a methyl off of it, indicating that, in fact, it does have a special name. And that special name is toluene. So all of this represents toluene. So it's going to end in toluene. Toluene is the parent name. Now, besides toluene, there are two substituent groups. One is a chloro and one is an ethyl. C comes before E, so it gets the name chloro. And it also gets, in the numbering system, this ends up being carbon number 1 because of the parent name toluene establishes this carbon as number 1. 1, 2, 3. So this is 3-chloro. Continuing in that direction, 1, 2, 3, 4, 5. This is 5-ethyl. So the name of this compound is 3-chloro dash 1, 2, 3, 4, 5, 5-ethyl toluene. So this is 3-chloro 5-ethyl toluene. All right, let's go with this compound. It's got a double bond, so it's going to end in -ene. The longest chain is 1, 2, 3, 4, 5. So it's going to be a pentene. Now we could number it 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. We're going to number it in this direction because we get to the double bond sooner by going in this direction. So this ends up being a 2-pentene. This is a 2-pentene, but it's configured in such a way that we have a trans structure. Trans being that these bulky groups are across from each other with respect to this double bond. So this is going to be trans 2-pentene. Okay, let's move and do this guy. So, all hydrocarbons, no, all single bonds, so it's going to be ending in -ane. This is an alkane. Longest chain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. So this is a heptane. And there are two substituent groups. This one comes first in this, counting in this direction, 1, 2, 3, 1, 2, 3, 4. Okay, 1, 2, 3, 4. So it's going to be counting in this direction. So 1, 2, 3, 4, 5, 6, 7. Okay, there are two substituent groups. There's a methyl, and then there's an ethyl. E comes before M. So we name this first with the ethyl substituent. Counting 1, 2, 3, 4. This is going to be 4-ethyl. 1, 2, 3, 3-methyl. Okay, let's do this guy. All right, we notice that there are 2 double bonds, but the compound does have a double bond, and it's a hydrocarbon, carbon and hydrogen, so it's going to end in an ene. But there are 2 double bonds. So that means we have to account for that, so we say diene. Longest chain, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Hept. So it gets called a hepta. Diene. So we throw in an A because heptadiene doesn't flow as well as heptadiene. So this is a heptadiene. Now we have to indicate where the double bonds are. There are 2 of them. And there's one here and there's one here. We use the lowest numbering system, so when we count in this direction, we get a 2, 4 dash heptadiene. Now, there's a substituent group. And if we count in this direction, that's number 1, 2, 3, 4, 5, 6, and it's a methyl. So that's going to be 6-methyl dash 2,4 dash heptadiene. Okay, let's do these structures on the second page. Let's do this first one. Now, in order to do this first one, we have to recognize several things about it. First of all, there are 3 substituent groups. One is an alkane substituent, one is a chloro, and one is this OH or hydroxy substituent group. As it turns out, the hydroxy has priority over alkane and halo, so it gets named after the OH. So, if we look at our cheat sheet, we will find this particular functional group under alcohol. It's a carbon OH, so this is called an alcohol, and alcohols end in -ol, -ol. So this structure is going to end in -ol. Longest chain, we already know this isn't the longest chain, so it must be this. 1, 2, 3, 4, 5. So this is a pentanol, and it's cyclized, so that's cyclopentanol. So this part here is cyclopentanol. Now we have to tell it which carbon the OH is bonded to, because there are 2 other substituent groups. So it's bonded to, and this gets carbon 1. So this is a 1-cyclopentanol. But we have 2 other groups. One is chloro, one is ethyl. C comes before E, so the numbering system is in this direction. So this guy is going to be a 2-chloro, so that comes first. 2-chloro. And if we continue in that direction, 1, 2, 3, 4, 5, this is 5-ethyl. So this compound is 2-chloro, 5-ethyl, 1-cyclopentanol. Okay, let's do this guy. All right, we notice that there are 2 double bonds, but the compound does have a double bond, and it's a hydrocarbon, carbon and hydrogen, so it's going to end in an ene. But there are 2 double bonds, so that means we have to account for that, so we say diene. Longest chain, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Hept. So it gets called a hepta. Diene. So we throw in an A because heptadiene doesn't flow as well as heptadiene. So this is a heptadiene. Now we have to indicate where the double bonds are. There are 2 of them. And there's one here and there's one here. We use the lowest numbering system, so when we count in this direction, we get a 2, 4 dash heptadiene. Now, there's a substituent group. And if we count in this direction, that's number 1, 2, 3, 4, 5, 6, and it's a methyl. So that's going to be 6 methyl dash 2,4 dash heptadiene. Okay, let's do these structures on the second page. Let's do this first one. Now, in order to do this first one, we have to recognize several things about it. First of all, there are 3 substituent groups. One is an alkane substituent, one is a chloro, and one is this OH or hydroxy substituent group. As it turns out, the hydroxy has priority over alkane and halo, so it gets named after the OH. So, if we look at our cheat sheet, we will find this particular functional group under alcohol. It's a carbon OH, so this is called an alcohol, and alcohols end in -ol, -ol. So this structure is going to end in -ol. Longest chain, we already know this isn't the longest chain, so it must be this. 1, 2, 3, 4, 5. So this is a pentanol, and it's cyclized, so that's cyclopentanol. So this part here is cyclopentanol. Now we have to tell it which carbon the OH is bonded to, because there are 2 other substituent groups. So it's bonded to, and this gets carbon 1. So this is a 1 cyclopentanol. But we have 2 other groups. One is chloro, one is ethyl. C comes before E, so the numbering system is in this direction. So this guy is going to be a 2 chloro, so that comes first. 2 chloro. And if we continue in that direction, 1, 2, 3, 4, 5, this is 5 ethyl. So this compound is 2 chloro, 5 ethyl, 1 cyclopentanol. Okay, let's do this next compound right here. As you can see, it's got a nitrogen, and it's got 2 alkyl groups bonded to it. So let's look at our cheat sheet and find out what we would call this thing. All right, so this is actually an alkylamine. It's got nitrogen with 2 carbons bonded on either side. So it's going to end in an amine, and the substituent group ends up being the alkyl. So here we go. We have a nitrogen with two substituent groups on either side. One is a 3-carbon group, one is a 2-carbon group. So as the cheat sheet says, this is going to end in an amine. The longest is 3, so it's going to take on that as its parent. So this is propanamine. So this part of it is propanamine. But it has a substituent group on, and that's ethyl. So this is going to be ethyl propanamine. Ethyl propanamine. Now let's name this guy. So this is an oxygen with 2 alkyl groups. And as it turns out, that's going to be an ether. So an ether is an oxygen with 2 carbon groups bonded to it. Ethers never get a parent name. They always are named after an alkane. And then the substituent group is an alkoxy. So here's our ether, an oxygen with carbon on either side. So again, it's going to be named, since everything else is a hydrocarbon, single bonds, it's going to be named after an alkane. And the alkane is going to be the longest chain. So that's going to be a 1, 2, 3, 4, or 1, 2, 3, 4, 5. It's going to be a 5. So again, it's going to end in ane. 5 is pentane. So this is a pentane. Right along here is a pentane. It has 2 substituent groups. It has a methyl group, and it also has an ethoxy group. So this is an ethoxy substituent group. This guy right here is a methyl. So E comes before M in terms of substituent groups. So this is going to start out with the E. So this group is called ethoxy. And that's going to be on carbon 1. 1 ethoxy. And the methyl group is going to be on 1, 2, 3, 4, 5, 1, 2, 3 methyl. So this is going to be 3-methyl. So this is 1, that's carbon number 1, 1 ethoxy, 3 methoxy pentane. Okay, here is another group that we haven't learned about yet, so I'm going to show you how to name this. This functional group is characterized by a carbon doubly bonded to an oxygen and singly bonded to an OH. Let's go to our cheat sheet and find this guy. Okay, and on our cheat sheet is part 2. This guy, here we see the same kind of structure, a carbon doubly bonded to an oxygen, singly bonded to an OH. This is called a carboxylic acid as a functional group. And it's going to end in anoic acid, anoic acid. So that's how it's going to end. Okay, so here we are. There's our carboxylic acid, and so it's going to end in anoic acid. Starting with this carbon, we're going to move in this direction. The longest chain is 1, 2, 3, 1, 2, 3. So it's 3. 3 is prop. So this is propanoic acid, propanoic acid. There is a substituent group we have to account for. Counting in this direction, that's going to be 1, 2. It's bonded to carbon 2, and it's a methyl group. So this is going to be 2-methyl propanoic acid. 2-methyl propanoic acid. Let's move on to this guy right here. Okay, this functional group is characterized by, this thing is called a carbonyl, carbon doubly bonded to oxygen. So this is a carbonyl. It has a carbon on one side and a carbon bonded on the other side. So let's look at our cheat sheet and find this critter. And here we see it right here. Carbon doubly bonded to an oxygen called a carbonyl. It's got a carbon on the right and a carbon on the left. This functional group is known as a ketone, and it's going to end as anone. Anone. So we're talking about this guy right there. So it's going to end in anone. Anone. It's a ketone. Anone. Longest chain, 1, 2, 3, 4, 5, 4, 5, 5. So that's a pentanone. So this is a pentanone. Pentanone. This carbonyl establishes the direction of numbering. Since this is carbon 2 in this direction, but carbon 4 in this direction, we're going to move in this direction. So 1, 2. We have to tell it where this carbonyl is located, and it's located on carbon 2. So this is 2-pentanone. Now we have to finally name this. It's a methyl substituent group. In this direction, it's on carbon 1, 2, 3, 4. So this is going to be 4-methyl 2-pentanone. 4-methyl 2,5-pentanone. Okay. Let's talk about this guy. This guy is a new structure that you haven't seen. And it is characterized by a carbonyl, C double bond O, singly bonded to a nitrogen, H2 and NH2. So let's go to our cheat sheet and find out where this is and what we name it. So here it is. Once again, we have a carbonyl doubly bonded to an oxygen, and that carbon is singly bonded to a nitrogen N2. So this is an amide, and it's going to end in animide or animide. So this is an amide. It's going to end in amide. Animide. Longest chain. That's 1, 2, 3, 4. 1, 2, 3, 4. It's 4. So that's going to be a butanamide. Since amides always start with the carbonyl as carbon number 1, we don't have to say 1 or 2 or 3. It's understood that it's always going to be 1, that this is always going to be carbon number 1. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. That's butanamide. So now we need to, let's go on that, name this substituent group. This is carbon number 1. This is carbon number 2. So this is 2-ethyl. 2-ethyl butanamide. 2-ethyl butanamide. So that's the naming of all these structures. Now, let's talk about chemical reactions. What are the chemical reactions? And you should make flashcards of these chemical reactions. So we're going to take this molecule, which is 1, 2, 3, 4. 4, so that's a butene. It's a 1-butene. 1-butene, the double bond starts with carbon number 1. So when this ionizes, the bromine is going to be negative and the hydrogen is going to be positive in water. So this is going to add across the double bond just like water adds across the double bond. So this is a hydrobromination reaction it's going to add. So this bromine could add to this carbon or it could add to this carbon, but like water, it's going to add to the carbon with the fewest number of hydrogens. So that's going to be that guy right there. And the hydrogen adds to this carbon. So the answer is going to be CH3, CH, here's where the bromine adds, and a CH2, and a CH3. 1, 2, 3, 4. 1, 2, 3, 4. So this is a butane, and it's a 2-bromobutane. So that's 2-bromobutane. 2-bromobutane. So I'm getting a little faster, so I named it front to back instead of the other way. Okay, we've seen this kind of reaction where the HOH are going to add this OH is going to add to that carbon, and this H is going to add. This is the Markovnikov rule. The OH adds to the carbon with the fewest number of hydrogens. In the case of this carbon, 1, 2, 3, 4. There are no hydrogens. In the case of this carbon, there is 1 hydrogen. So let me also designate that up here as well. Okay, so let's draw the product of this reaction. It's going to be a 5-membered ring. Here's our methyl group, and our OH is going to be here. Now, this is an alcohol because of the OH functionality, and as you remember, based on the cheat sheet, it's going to end in anol. Longest chain, 1, 2, 3, 4, 5, so it's a pentanol. Pentanol, it's cyclic. So it's cyclopentanol. Since it's the parent compound, the OH is understood to always be bonded to this carbon, which ends up being carbon number 1. Now, we have a substituent group that we have to name, and it is a methyl group. And it is also bonded to carbon number 1. So this is 1-methyl cyclopentanol. 1-methylcyclopentanol is the product of this reaction. Okay, let's do this guy. This is going to be a bromination reaction. Bromination, where bromine gas is going to add across the double bond. One of the bromines is going to go there, and the other one is going to go there at that carbon. So the answer is going to be CH3-CH. Here's where one of the bromos go, CH. Here's where the other bromo goes, CH2-CH3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is going to be a pentane. Two bromos on carbon 2 and 3. So this is going to be 2, 3 dibromo pentane. 2, 3 dibromo pentane. All right, let's do this reaction. This is very similar to the reaction we did up here, in that HCl is going to add across. Markovnikov rule, the Cl is going to add to the carbon with the fewest number of hydrogens. In this case, there are no hydrogens. And the H is going to add here, where there's one hydrogen. And the product looks like this. Here's the methyl. Here's the Cl. And the name of this is hydrocarbon, single bonds, ane. 1, 2, 3, 4, 5, 6. Hex. It's a hexane. Cyclo. Hexane. Two substituent groups, methyl, chloro. The chloral comes first. So this is going to be 1 dash chloro dash 1 dash methyl. So this is 1 chloro 1 methyl cyclohexane.